It is time to take a look at root guard in both theory and in action. And to do so, what I did between videos was do a right erase on all three switches you see here, 1, 2, and 3. And also remind me, what's the command I ran to make sure all the VLAN information is gone? Delete VLAN.dat. Ran that as well. And when the switches came back up, I changed the priority for 2 of them for VLAN 1 only because we're going to stick with the defaults here for our VLANs. We don't need any extra ones. So switch 1 has a priority of 8192 for VLAN 1, switch 2 a priority of 16384, and switch 3 we left at 32768. We'll go ahead and verify that switch 1 is indeed the root, and we see the magic phrase there, this bridge is the root, and a priority overall of 8193 with that system ID extension number for VLAN 1 added. And that is it. So all is well, but we also know that the root bridge election process is not static. It doesn't happen one time and then a root gets elected and that's it. We know it's an ongoing process. BPDUs are being generated by the root bridge. They're being forwarded by the non-roots. And in this way, if something happens, the change can be adapted to quickly. And in this particular case, maybe it's a change we don't want. Because switch 4, which is not online yet, that's why switch 1 is seen as the root. But if this happens, and I have a feeling it just might in a moment, if switch 4 comes online and it has a priority of 4096 for VLAN 1, then in effect it's sending a superior BPDU into switch 3. And switch 4 should, in quick measure, become the root for VLAN 1. So what we'll do is actually test that first, and then we'll proceed with the root guard portion of this lab. Now, switch 4's priority has already been set to 4096 with the spanning VLAN priority command, and all I should need to do over on switch 3 is open the port that leads to switch 4. And let's make sure that comes up, the trunk comes up, everything else looks good. It's looking good so far. There's our interface. We'll run show interface trunk. And we definitely have one out, fast Ethernet 4. And now let's run show spanning VLAN 1. And you can see that the change has already taken place. So switch 4, which we'll now go over to and just absolutely verify, is indeed the root for VLAN 1. This bridge is the root. So maybe that's perfectly fine with us, but then again, maybe it ain't. Because the thing is, if we go to the trouble of using the priority command or the root primary and root secondary commands to say, okay, I want switch 1 to be the root, then maybe we had a really good reason for that, and we don't want another switch coming online later and taking over that role. Also, this switch 4, it could be what we call a rogue switch. It could be a switch that's been connected to our network and it's communicating with our network devices, but it's not under our administrative control. And that's a real fancy Dan way of saying, hey, something is wrong here and the bad guys have gotten a switch in here. So maybe we want to guard the root role here and make sure it stays with switch 1, and that's what root guard is all about. Now I will take 4 out of the equation right now. And that's it. So we'll hang out here. This is what I love about a lab. We'll hang out here while that goes down and see, or she. And right now it's recognizing itself as the root, but I don't think that's going to last very long. And it didn't. So now you can see the root bridge election has taken place. The priority of the root is 8193. We know that's router 1, but we're still going to look. We must know. And there we go. This bridge is the root VLAN 1, and that is switch 1. So we are back to where we were before. What we want to do with root guard is prevent another switch downstream from the port where we configure it from becoming the primary or the secondary root. And I really want to draw your attention to the fact that we're configuring this at the port level. And when we get to the results of it, I want you to take special note of what's going on. Because it's easy to think with root guard, and we're going to have another one called BPDU guard, and we're going to have some other features with our switches that put ports in different kind of modes, but they're not always shut down. You know, like with port security, we saw that when something happened to a port, when there was a violation in default mode, in shutdown mode that is, then the port was actually put into error disable mode and it was shut down. That is not always the case with some of these switching features, including root guard. So just a little teaser there. We'll take particular note of what happens with root guard when we have a violation. Now again, we configure it at the port level, and no switch downstream from that port can become the primary or the secondary. Again, with these features, we have to take note of where it should be enabled. And to prevent switch 4 from taking over either the primary or the secondary roles, we would need root guard configured on switch 3's port that leads to switch 4. And we know what that is just from this lab. We know, let's try 6, that is going to be interface 0/4. And the command is a little odd here. If you're looking for spanning root guard or something like that, that's not actually what you want to do. What you want to do is do a spanning and then guard and then root. And then finally, that's what we want. So spanning guard root, we've now enabled root guard on Fast Ethernet 3. And to see what happens when root guard takes effect, we need to go ahead and open up switch 4 again, right? We need to open this port up. So let's go ahead and open that up and let's watch what happens. Again, spanning guard root is the command we wanted there. The interface comes up and look at that. We've got a very special message right in the middle of all that, even before we get the message about the line protocol. And it's root guard, span tree, root guard block. So it's telling us exactly, what's going on, what did it, and the actual event. And root guard is now blocking port Fast Ethernet 04 on VLAN 0001. So what happened was a superior BPDU came in on this port. It would have changed who the root bridge was, as we saw it did before we enabled this feature. And the port was, well, it was blocked. But did you see anything here about it being actually shut down or put into error disabled state or anything like that? No, because it isn't in error disabled state. If you run show interface 0/4 right now, check this out. That interface is up physically and logically. So root guard is not going to shut this port down. It's actually still up. Now let's run show spanning, a new one here. Inconsistent ports is what we're actually going to look at. And I'll just run incon and see if I get away with it, and I could. So show spanning inconsistent ports shows you from left to right the VLAN, the actual interface, and what the inconsistency is, because root inconsistent is what is the state of a port when root guard is enabled on it and it receives a superior BPDU. Root inconsistent. So it's something going on there, but it didn't shut the port down. That's a very important detail to note. Now let's run show spanning VLAN 1. And you'll notice that you actually still see that interface here. 0/4, there it is. It's a designated port, but the status is BKN, and there's a big fat asterisk right next to it. And the explanation for that asterisk is given later in that same line. It's root inconsistent. The reason I'm hitting you over the head with this about as far as the root inconsistent, the fact that the port is not shut down, is that the port is still listening for BPDUs. So if that priority changes over on switch 4 and it becomes an inferior BPDU coming in instead of a superior BPDU, then theory holds that the port will come out of root inconsistent mode and it will operate normally. Well, let's go ahead and find out. I know we're at the 9-minute mark here. I like to keep it to 10, but let's see what's going on here with 7. What I'll do is use spanning VLAN 1 priority, but I'll set it at 32.768, and then I'm going to head back over to 3 very quickly, because the change should actually take effect very shortly. With that priority changing to 32.768, now we have an inferior BPDU coming in. Okay, it's still in root inconsistent. Let's give it a second. And as soon as I said that, I knew it would happen. You can see that message, span tree root guard unblock. Root guard is unblocking that port. Pretty cool stuff there. So again, very important line to draw here between root guard and the next feature we're going to look at, which is BPDU guard. With root guard, the only thing that can happen that triggers root guard is a superior BPDU. And we saw exactly what happens. The port stays up physically and logically. It goes into root inconsistent state, and that's really about it. But if that superior BPDU then becomes an inferior BPDU, then an inferior BPDU comes in and a switch says, hey, okay, the superior one is no longer coming in. I'm going to unblock this port. So that's pretty great stuff. It's a great way, again, to guard the identity or the role, if you will, of that root switch. But, there's that word again. But what if we don't want any BPDUs coming out? Absolutely no BPDUs at all. We're saying, hey, there shouldn't even be a switch on the other end of this connection. And if there is, I want something done about it. That's where BPDU guard comes in, and that is coming up next.